5.6. We are starting into law of cosines, which is our last lesson in chapter 5. Law of cosines works along the same idea of law of sines in that you know certain pieces in non-right triangles, you can find other missing pieces, right? The differences here are what you have to know and that type of thing. But, okay, in any triangle ABC with angles A, B, and C, opposite sides A, B, and C respectively, the following equation is true. Now, hold on. I forgot to change the typo. It's one of those days. Okay, so first of all, this is the law of cosines. If it's the law of cosines, you would expect to see cosine. Okay. I'm going to zoom in because I want everyone to be able to see that. So, one version of the law of cosines is a squared equals b squared plus c squared minus 2bc times the cosine of angle A. Okay? The idea when we get down here is this is the type that can work, if you're just given three sides of a triangle, you can use this to find, start finding missing angles. So, this is one version. Everyone caught that I changed that sign to a cosine, yes? Now, you'll notice there, it's kind of off the side of my paper, but it says this equation is also true for B and C as well. So I'm going to write those in because I think you guys will do better if you have them physically in front of you. They're not typed in there, but so notice here it's a squared. The other two sides are right here, b squared and c squared. And the other two sides are right here, 2bc. Whatever side is over here, a squared, is the angle that is in here, cosine A. So, the point is we can also write one that starts with b squared. If it's b squared, so if that's the side that's on the left, the two sides being added right here are a squared plus c squared minus 2, using those same sides, ac times cosine of angle B, because side B is what started this equation. Okay, that's one version of it. And we can also have a third version of it, yes? This one starting with C squared. So C squared is the side that starts it. Then the two sides being added are A squared plus B squared minus 2 times those sides I just did, so 2 minus 2ab, always cosine, and this time it's cosine of angle C. So you have 3 variations of law of cosines that you can use depending on the situation. Okay, it looks totally different than law of sines, but the idea behind it is the same. Okay. Side note there, and this is just basic triangle knowledge. Basic triangle knowledge says that 2 sides of a triangle must be bigger than the third. Okay, it's not physically possible to have 2 sides of the triangle that add up and they're smaller than the third side because they wouldn't even be able to reach each other. Okay, so that's going to be one of those catches today that we could run into a situation where a triangle does not exist. So anytime you're given 3 sides, make sure that the 2 smaller sides add up to be bigger than the larger side. Okay, that will be one of the catches there. Now, when solving triangles with law of cosines, okay, so today's law of cosines, we can use the setups of side angle side and side side side. The key with solving law of cosine problems, are you catching this right here? We always find the smallest angles first in order to take account into obtuse triangles. Okay, so we always want to, when working with law of cosines, it's just kind of how it's set up and works. because when I punch sine on my calculator, or cosine, or tangent, it automatically gives me the acute angle. So if I'm supposed to be getting an obtuse angle, I'm not going to get it. And so that's why if there's an obtuse angle, that's when we're going to find at the end by all three triangles add up to be 180. So key information there. We're always going to find the smallest angle first. And it can make a difference. I'm not going to say it will always make a difference, but it can make a difference in some of these problems, so good habit to be in. Okay? Let's see, did I get everything covered there? I think so. Let's look at example 1. Notice it says solve triangle ABC. So again, that is find all missing sides, right? We're given that side A is 11, side B is 5, and angle C is 20 degrees. This problem right here could not be done with law of sines. Because in order for law of sines to work, you have to have an angle and a side that are opposite each other, yes? You have to have a matching pair. I have an A, a B, and a C. I don't have anything matching. So this is why we have to go to law of cosines. You guys want a picture?
Yes.
Let's do a picture. Don't make it too big. I hope I didn't make it too big, because I've got to allow room for all my work, of course. Okay, so angle C is 20 degrees. Side A is 11. Side B is 5. So basically, the way I drew my triangle, I've got the left half of the triangle, we have to find the right half of the triangle. Okay, start by trying to figure out, based on law of cosines up there, I know side A, side B, and angle C. Based on the fact I know angle C, which version of law of cosines do I need to use? I'm going to have to use the one that is C squared, because I have angle C, sides A and B. Okay, so this math, there's a lot of just writing down and punching into your calculator, but this is not bad math here. So I'm going to write out my law of cosines that C squared equals A squared plus B squared minus 2AB times cosine of C. Not that you have to write it out before you filled in, but I just feel like that's a good beginning step as our first experiment with this. Okay. Fill in the numbers. C squared, I'm going to be looking for side C to begin with. So C squared equals A squared. So 11 squared plus B squared, so plus 5 squared, minus 2 times 11 times 5 times cosine of 20 degrees. So far so good. All I did is fill in the information. Mathematically, you technically could just start plugging it all into the calculator. I'm going to do a little bit of work by hand first. 11 squared is 121, plus 5 squared is 25, minus, I'm going to go ahead and say, what is 2 times 11 times 5? 110 cosine of 20 degrees. And as I said, if you punched in the whole thing originally, you're good. Okay? Mathematically, what's my step that's done next? Well, okay. Okay, so what I'm going to say is what you can do here, different people are going to do this different ways, you can go ahead and add 121 and 25. Can I go ahead and subtract 110? Why not? This 110 is attached to the cosine 20, yes? So it's not just a plain old number. Now, if you put this all into your calculator is going to understand it's attached. But if you're trying to work part of this by hand and you just start, okay, 121 plus 25 minus 110, and just come up with one number, that's a problem. So 121 plus 25 is 146 minus 110 cosine of 20 degrees. We have now officially hit that point. You have to go to the calculator, right? If you haven't already gone to the calculator, it's time. Of course, my calculator is still in degrees mode. And you can honestly just go ahead and do 146 minus 110 cosine of 20. It should be. You'll find out here in a moment, right? So I get this number right here, yes? So what is that number equal to? So c squared is this 42.6338, so on and so forth number. What's my finishing step? To square root it, yes? Now, be smart with your calculators, yes? Even if you're using a scientific, you could do square root and then ants, which is the previous answer. So even if you're using a scientific, you can do that. Personally, what I like to do is set up my square root. Remember, on some of these calculators, you can arrow up. And notice it's highlighted. I can copy and paste it. And I can get that right there. If I go one decimal place, this is approximately 6.5. Technically, if we wanted to, we could have done square root, and we could have just typed in 146 minus 110 cosine 20. You'll find out some shortcuts and figure out. Now, obviously, I expect to see some basic work written down in your paper, yes? Don't just plug it into your calculator and give me no work. That does not fly.
Now we use sine to finish the problem. Or do we still use cosine?
We're going to use cosine. Okay, so good question. Hans's question is, so now we use sine to finish the problem. And here's what I'm going to say. Okay, so could you possibly use law of sines at this point? Yes. I'm not going to encourage it this exact moment. Seriously? I'm not going to encourage it at this exact moment because we need to practice law of cosines here. And my seriously was, I didn't realize it was 10:13 already. I thought I could at least finish this problem. So, I guess we will leave off very awkwardly in the middle of this problem. And we will work to find our angles tomorrow. Okay? Have a good day.